If you imagine that you have two pencils and you sharpen those pencils at both ends, you've now created two electrodes. And if you attach the tops of these two ends, these sharpened pencils, to a 9-volt battery, and you stuck them in water and added a little salt, like sodium chloride table salt, you would actually see bubbles coming off one electrode and bubbles coming off the other electrode. And you would have oxygen molecules coming off one and hydrogen coming off the other. That's called water splitting, and that's electrolysis. So what's going into the engine is the fuel and an oxygen-hydrogen mixture coming from the electrolyzer.
Back in 2008, this all started when gas prices were approaching $4 a gallon. So we decided that we needed to do something to combat the fuel costs.
Our fuel system are out here. There's two 10,000 gallon tanks. One is diesel, one is no lead. And this is one of the reasons that we're trying to work with this technology. I get a tanker load of fuel about every week and a half. So that's between 7,000 and 10,000 gallons of fuel. We got a little over 300 pieces of equipment currently. When you use the hydrogen fuel cells on these vehicles, hydrocarbon particles per million drop tremendously. So there's a lot less pollution coming out of the exhaust. That's due to a clean combustion and because of the added hydrogen to the combustion cycle.
The City of Beloit's hydrogen project follows the established goals set up by our City Council, which is to, number one, promote sustainable stewardship for our community. Number two is to apply sustainable practices. And third, which we're doing with the university, is to proactively partner with others that will cause a healthier City of Beloit.
Our main goal is obviously fuel economy, to increase fuel economy in all of our fleet vehicles, and also to reduce our emissions. Right now, our fuel budget is roughly $710,000, and if we meet our goal of 25% savings through this program, the city will save $177,000, and so that's pretty substantial.
If a city has non-compliance with respect to emissions, they can use these electrolyzers to put their vehicles on the streets.
This operation, when we first put it on there, we got it in a box, and it took us about 6 hours to put it on. And it's the most basic of the systems, being one cell and one computer box. How do we open the hood on one of these? I don't know. First off, we find a location to put the cell and mount it in a good safe area. And then the computer box itself is all weather tight, so that could go pretty much anywhere. And then the electronics, there's an electronic controller that's in the cab for controlling amperage and some of the other parameters that we have for the cell. Okay, what we have after that is we're installing the tubing, which runs through the cell, through the water bottle, the circulation bottle, and then out and through to the intake manifold. And then you have to drill a 3/8 hole through the intake manifold and put a probe in there that expels the hydrogen into the intake. This one's been running for over a year now. This is our best mileage getter. It went from like 16, 17 on up now, like what, we've been getting 26 miles per gallon.
There is no comparison. This one has much better pickup. The gas mileage is incredible. And I stop a lot and shut the vehicle off, get out, go on for 5 minutes, come back in, take off again. I have incredible mileage.
We've only run 2 of them in the winter, and they were on supervisors' vehicles because they're inside a lot. The rest of them we actually shut down for the winter because the freezing points, and if they sit outside for more than 4 hours or 5 hours, then they'll start to freeze up. The circulating pumps, ones that actually have a pump circulating, we can go longer. They use about a Dixie cup full of water a week, is almost all of our systems do.
We currently have 5 test vehicles in our system that we're testing different types of hydrogen systems on. We monitor all these vehicles every week as to the fuel mileage. We do emission readings on them. We do base readings, then we do periodic emission readings throughout the year. One of the vehicles is actually got a dry cell hydrogen fuel cell in it with a coating process that has been applied by the university.
What we do is we make self-assembly nanoparticles. So after we make the nanoparticles, what we then do is coat them on a substrate. So here's an example of a carbon substrate. And what happens is if you take this substrate and then coat it with the nanoparticles, you can dramatically improve the performance of the substrate by having the nanoparticles on the electrode.
By coating these 2 electrodes, we can produce more hydrogen and oxygen with the same 9-volt battery than we would before. Alternatively, we can do that at lower potential. So that instead of 9 volts, let's imagine that we could do it at 7 volts. So we actually lower the amount of energy that we need to produce hydrogen and oxygen. If we have a surface area of, let's say, 6 square inches, with our nanoparticles, we multiply that by 200 times. So the surface area is increased enormously.
We identified a lot of major issues that we were having with the vehicles, with the fuel cells. Was introduced to Professor Mark Anderson at the university. I wanted to get him involved and get some more science involved in how these fuel cells actually operate. It kind of became a class project for the UW for this 160 students to resolve some of the issues for the city of Beloit, which they did. And we're going to be doing the same thing again this year.
So the students coat these plates, put them in an electrolyzer, and apply the potential that's coming from the Vespa. So we actually use the battery alternator combination of the Vespa to split the water. So we have a tank of water in the Vespa, and we're using the battery and the alternator to feed the oxygen and hydrogen, or to generate oxygen and hydrogen, which we feed directly into the engine.
So it's kind of a group effort between the city of Beloit, between our suppliers, and the university. Once we come up with prototype units, they will be installed in the city of Beloit's fleet of vehicles for testing.
In the future, our job here at the University of Wisconsin is to produce better materials that don't corrode, that can function at higher voltages, and produce larger currents and more hydrogen and oxygen in a given volume. And that's from a research point of view. These will ultimately get incorporated into commercial products.
Once you understand how the technology is designed and how it has to work, how it has to interact with the vehicles, you will get good results with it. When we have a product that works for us, that is what I call grandma proof, I will tell people that, and then I would recommend buying that. At this point, there's not a fuel system out there, at least a hydrogen fuel system out there, that is bulletproof. They all have inherent problems, so and we're trying to correct those things.
We look at the system, or this project, to be able to help our city financially and environmentally. So if the hydrogen project can help us in those 2 areas, it more than does what we set out to do.
We work for the taxpayers of this community, and that was our goal, is to do something to help the community. And that's reducing our costs through technology.
It's wonderful. I like to see it on all. So.